Good morning, friends. This is Professor a.k.chaubey. Professor Chaubey's physics class under the heading Physics Made Simplest. So we were discussing AC circuits, AC or that is alternating current, and now I am going to discuss some more about the AC circuits, that is the resistance, AC applied to resistance, AC applied to inductance, AC applied to capacitance, etc. So before that, I talk about something about the phasor diagram. We represent AC potentials or currents by phasor diagram. The phasor diagram means this circle I am showing here, this O point here, center. This means, and the AC alternating current or potential, this is 0 here. So this is, say, T is equal to 0 here, T is equal to 0 here, and T is equal to 0 here. So that the motion of this vector OP starts from this line, say OA. OA is the line where this vector OP starts flowing at T is equal to 0. Means current starts increasing from here as potential applied. As the time passes, the phasor diagram, we represent the current vector moving anti-clockwise direction, so that at certain time t, making angle theta, this vector is OP, and OP, the current at this time is, say, I. So this current equal to OM is the current vector, is OP sin theta. So that is OP sin theta. OM is equal to OP sin theta. So this current here represented on this sine curve here, that at time equal to such that this angle is theta, the current is I, this thing. And at this time where the angle is pi by 2, this pi by 2 current becomes maximum, and that is I naught. And when this vector goes to this side, here, angle you can say this is pi by 2, this is more pi by 2, so this is pi. So this pi here, the current becomes 0. And then the reverse, that is the opposite direction, the angle increases further to 3 pi by 2, current again becomes maximum. Here also this vector is I naught. So this is the current becomes here at 3 pi by 2, I naught here, this is also I naught. And at angle 2 pi, that is the omega t. That omega t represents the angle actually, because omega is angular velocity. Angle traverse in unit time. So omega into t means angle traversed here. Theta means omega t. So we can write here OM or the current I, OP maximum I naught, I is equal to I naught sin omega t. Omega t means the theta angle traverse in time t. Omega is angular velocity, means angle traverse in unit time. So this is now representation of current I is equal to I naught sin omega t. Where potential applied to any circuit is E is say E naught sin omega t. So potential is represented here. And if I have a circuit like, say, a circuit where we have resistance only, a circuit where the potential source is connected to resistance only, means we have a circuit where we have simply R. The R is connected with, say, AC source. This is the symbol representation of AC source. Through a key, of course, we apply a key here. So when we press the key, well, this current starts passing through this. So current starts passing, and this EMF is, say, E is equal to E naught sin omega t. Means the potential also increasing like the same thing. That is the potential represented also in like same diagram, that E this is a time omega t, the angle theta, and this is the E, and this is the maximum E naught. So potential, and this is the maximum minus E naught, opposite sign. So potential represented by the applied source E varying such that the same frequency omega and maximum E naught plus or minus. Here the current is I naught sin omega t. We can see here that as the Ohm's law, current, you can write that current is, so I is equal to I or potential drop here, the E is the potential drop, E is over R. This E over R means current. Current is E over R, and you can write that, what is I say, E naught sin omega t over R. So E naught over R is the current, maximum current, E naught over R is equal to I naught, maximum current. So you can write I is equal to I naught here, sin omega t. So this means that E, potential applied, and the current, potential applied on the resistance R, current increase in the circuit such that current and potential both are in the same phase. Because it is the I naught sin omega t, here E is E naught sin omega t. So both are in the same phase. Wherever potential is maximum, current is also maximum. Wherever potential is zero, current is also zero. So both you can show on the one diagram, same diagram, that potentials and current are in same phase on the resistance only. So I is equal to I naught sin omega t is written here. Now you can see that so now we write say where you see this, what is the power absorbed? Power. When we apply some potential EMF source, current flows, what the power absorbed? You know, power absorbed is simply P. Power is defined as voltage into current. V is equal to E into I. That is a V into, if V less than DC, V is the voltage, C is the current, then V into C is the power. So this is the power, and below that E is E naught sin omega t. I is I naught sin omega t. So power absorbed will be simply power absorbed P is equal to E naught I naught sin square omega t. This is the power absorbed. And you can see that this means E naught I naught, what the sin square omega t, we can write in terms of cosine. 1 minus cos 2 omega t. This is the cosine. So divided by 2. We got 2 sin square omega t is equal to 1 minus cos 2 omega t. So this is the sin square omega t. See the trigonometry. And this means that we can multiply E naught I naught, E naught I naught by 2, and here minus E naught I naught by 2 cos 2 omega t. This is the power P. Remember that average power, now we have average power means this is the time varying. So average power for one complete cycle. Means one cycle where voltage starts from 0, goes to maximum, then 0, then negative maximum, and then again 0. So for one complete cycle means from 0 to 2 pi angle. That we can write that P average power P, we write by the capital P or this capital power. That is, the average power is average over full one cycle, 1 over t. You divide by time and 0 to t, full cycle, integrate of this E naught, I naught by 2, and yes, dt, and then this factor minus E naught, I naught by 2 cosine 2 omega t dt. This is our full cycle, one cycle. So in this way you can see that E naught I naught by 2 cos 2 omega t, integrate this, cos 2 omega t. So integral 0 to t cos 2 omega t. Well, cos 2 omega t dt. This is full one cycle, means 0 to t, full one sine curve. So you integrate this and put the limit, you will get. Or you can see that for one complete cycle, for half cycle it is positive, for half cycle it is negative. So that means because integral of this is equal to 0, so what you get? This thing is 0. So this becomes 0. And what you have only, you have power is equal to this. Integrate this, E naught, I naught, this is a constant, and t is a 0 to t. So t and t this cancels. So this is simply E naught, I naught by 2 minus this is 0. This means that power is E naught by under root 2, I naught by under root 2. These are the RMS value. So you can write that this is simply power P is equal to E naught by under root 2 into I naught by under root 2. This means power is E naught by root 2 means RMS value or average value. So you can write this as EV and IV. That is average value, or you can write RMS value. ERMS you can write. ERMS, IRMS, or average value, EV and IV. So this is the IB average value. IB is, IB means average current for the circuit having R only, EB over R. That is IB. So IB you can write EB over R here, or then if you write IB as EB over R, then the power becomes EB square over R. So this is the power, average power, EB, because I told you the heating effect is same whether current is going the positive direction or current negative direction. If you measure this current or voltage by some proper ammeter voltmeter, this will give 0 reading because average means 0. But the ammeter or voltmeter based on the hot wire ammeter means based on the heating effect. So it will heat the wire whether the current is in the positive direction or again in the negative direction. So current both way is heating. So heating means this power is average means you add when the current is positive or current is negative. It is the temperature always increasing. So average power is EB square over R. Now we have some simple example. Then AC circuit consists of pure resistance, a problem. An AC circuit consisting pure resistance only. Let me have some other pen, because this becomes dry. So an AC circuit consisting of resistance only, consisting pure resistance of 10 ohm. The resistance in the circuit is, that is a 10 ohm. Across an AC supply of 230 volt. And 50 hertz frequency. There is a supply of 230 volt and 50 hertz. That is the frequency, omega. So that is now calculate the current power dissipated and power dissipated third, voltage and current equations. So now what we do? We have EB, RMS value. There is a measured voltage RMS or average. So EB is equal to 230 volt, R is equal to 10 ohm, and F linear frequency is 50 hertz. And so you find out now current, circuit current. IV is equal to EV over R. So 230 over 10. So current becomes 23 ampere. And we know that power dissipated is EB into IB, that we have already calculated earlier. So that is EB into IB means IB is 23, EB is 230. So 230 into 23. So this will multiply, and this will be 5290 watt. So this is a power dissipated. And now you have E naught is equal to, that is the maximum value. E naught over root 2 is equal to EV. So E naught is root 2 into EV, that you know. And similarly, I naught is under root 2 into IV, average value. So from this, you can find out E naught and I naught. So E naught is under root 2 into 230. That is 1.41, so you multiply by that and you will get 325.27. And I naught is equal to under root 2 into I, 23. So this is multiply, this is 32.52. Ampere. And omega, of course, angular frequency is 2 pi f. You have 2 pi into 50. So 2 pi means 2 into 3.14 into 50. So 100 into 3.14. So this becomes 3.14. That is the radian. 314, because 3.14 is pi. Pi into 100. And so this is the, now you have asked the volt and current equations. So that you can write. Because I is equal to I naught sin omega t. So you can write the volt and current equations also, that E is equal to E naught 325 sin omega t, omega is 314 into t. And I is equal to I naught is 32.52 sin 314 t. So in this way you can write, you can solve some problem. I have given just example of one problem. Simple circuit involving EMF, AC EMF and resistance only. And the current flows through resistance. How we get the value of the current, maximum current or maximum voltage, etc., etc. Now we have, say, AC circuit containing, say, key here, and then this is the AC source, and then this is the circuit here, current flowing here. This is the L inductance. AC circuit inductance only. So we have AC circuit having involving inductors only, and then we see what is the function of using inductance. Inductance, self-inductance, that is current passing using Lenge's law. The growth of inductance opposes the growth of current. That is that acts as a resistance. So inductance, if the current increasing here, this will oppose, because a back EMF is produced at the inductance coil, and that opposes the growth of the current. So it resists the flow of current. So inductance also works like a resistor. So we can now say, when potential E is applied here, E naught sin omega t. Current starts flowing immediately, and then current, say, opposing means opposite current. So that means what is the EMF produced? I is the current in the circuit. If I is the current in the circuit, then and di dt is the rate of change of current. Current change in the circuit di dt, time dependent of current. Then you know that then EMF induced is across inductance L is how much? That you know, proportional to L di dt, that is L proportional to di dt. So EMF introduced E is equal to minus L di dt. The induced EMF, because it is the back, opposite, so minus L di dt. So therefore, as this will send current opposite side. So that E becomes now, the potential drop here becomes minus opposite, because it is opposing. Potential induced L di dt. So this is E is equal to by small e. E is equal to minus L di dt. That is the potential drop. The voltage opposite to induced EMF is. So this is the voltage drop there. E is equal to L di dt. So E, we can write E is equal to E naught sine omega t, and E naught, E is equal to this thing. So you can write that L di dt, L di dt. This means that di is equal to E naught over L, E naught di is equal to E naught over L sine omega t dt. So integrating both sides we get here di means integrate means current I, and this is E naught over L. Of course, this is the constant, E naught constant maximum value, L is the inductance. Sin omega t, integrate this cosine minus cosine omega t, and then put the limits. That integrating means that over 0 to t. That integrate this over the full cycle, 0 to t time. So I is equal to E naught over omega will come from here, omega L, and sine omega t, that is the minus pi by 2. That is only 1 when you integrate cosine omega t, minus cosine omega t. So when you put time, omega, you put t is equal to t is equal to 0. So when you put t is equal to 0, you get 0, sine 0. So that is sine omega t. You can write sine omega t minus pi by 2. So that is the integral of cosine omega t, omega here, and put cosine omega t limit here, t is equal to 2 pi over omega. So that will give you sine omega t minus pi by 2. I is equal to E naught over omega sine omega t minus pi by 2. The value of I will be maximum. Let us say E naught omega L is equal to current I naught. So that means I is equal to, which gives I is equal to I naught sine omega t minus pi by 2. What does it mean? That there is a phase difference in potential and current. And potential is E equal to E naught sine omega t, current is I equal to I naught sine omega t minus pi by 2. Means, because inductor is opposing the growth of current, so that means there is a phase difference of pi by 2 or 90 degree between the potential and the current. And you can make the diagram like say this is the EMF, this is the E naught here. Then the current is having a phase difference of pi by 2, means when this is 0, E0, current is opposite, means opposite maximum maybe here. And then current increases. So that way it has got a phase difference of like this. So there is a phase difference between current, this is a current, and potential. When current, potential is maximum, current is 0. This here. And then this like this. So there is a phase difference of pi by 2 in the potential and current. That is, current lags behind the potential. By pi by 2, there is only inductance. If you have R and L both, it will be different. The phase difference. This is the called phase difference between the potential and current. Current is behind because the inductance is not allowing the growth of current. So current lags behind the potential. Now, what we can do, something more. So we know now resistance and we know inductance has got. Inductance has got an opposing resistance that is called reactance. To have difference in the resistance and the because inductance also behaving like a resistance for the growth of current. That is called inductive reactance, inductive resistance, reactance that is equal to inductive resistance. So that is I naught is equal to E naught over omega L. This factor is reactance. This is reactance. That is the E naught over I naught. Omega L is equal to E naught over I naught. So this factor, this is called reactance. Or we write by XL. XL is equal to omega L. This is called reactance. Or omega L means 2 pi F L. So we can use this all. Average power consumed, you can have average power consumed you can get simply by E is equal to, you write E is equal to E naught sin omega t, and I is equal to I naught sin omega t minus pi by 2. So that way you can write that this is minus I naught cos omega t. So P is equal to power is equal to E naught I E into I. Power is equal to EI. So that is the E naught sin omega t into I naught cosine omega t. So that is E naught I naught minus sin omega t cos omega t. 2 sin omega t cos omega t is the sin 2 omega t. So that is, you can write here. This is of course with minus sign, minus here. So this is simply minus here. So E naught I naught and sin omega t cos omega t is the sin 2 omega t, and this is a minus E naught I naught divided by 2, because 2 sin 2 omega t is sin omega t. Sin 2 omega t is twice sin omega t cos omega t. So that 2 cancels, then you get same thing. So this represents the average power, the E into I. Now you find out this is the E into I, means you can name this instantaneous power. This is called instantaneous power, means power at any time, any moment. And average power, you know, will be average power means average over full cycle. So that is capital P. You can have 1 over T, 0 to T, and minus E naught I naught by 2 sin 2 omega t dt. So that becomes average. Find out this, that integral of this, and see the limit. The average power P is equal to 0. Inductance for half cycle, it is opposing, and when the current starts decreasing, inductance gives the energy stored in the inductance that is magnetic energy converted into electrical. So that is for half cycle, it is plus opposing, half cycle is positive. Means when the current increasing, inductance starts decreasing. When the current decreasing, inductance increase the current because it gives the power. So average over full cycle inductance and only inductance of circuit average power is 0. So friends, we stop at this place and I thank you for listening to me. Maybe next time we meet we will discuss the inductance, we will discuss the AC source on capacitance only, and then we will do some problems. So thank you very much.